Good evening, sir. Today I have present my topic in transmission media. So I am Selvamurugan. Um, First, we have to know what is a transmission media. What is the purpose of this transmission media? So transmission media is nothing but it's a communication channel. It can carries the information from the sender to the receiver. So whichever the data is transmitted through electromagnetic signals, the main functionality of the transmission media is to carry the information in the form of bits through the local area network. So here I have showed the transmission media and physical. It is come under the category of OS layer in physical layer. Okay, so here I have shown that the sender is in the physical layer. So first there is a sender and there will be receiver. So in between that there is a transmission medium. This is the channel. Okay, this is a channel between the sender and the receiver. So it may be it may be a wired or cable or air medium, whatever it may be. So it is a transmission medium. So next is that we have to see the classes of transmission media. The transmission media has two classes. One is guided and another one is unguided. Guided means it is wired and unguided means it is wireless. Wired means that what are the wired channels? We can see this twisted pair cable. First one is twisted pair cable and another one is coaxial cable, and next one is a fiber optic cable. In unguided there is only one, that is a free space. So let us see one by one. So first we have to see what is guided media. Guided media is a media that which are those that provide a conduct from one device to another, including twisted pair cable, coaxial cable and fiber optic cable. So first we have to see this guided media. So in this we have to see in these three topics. First one is twisted pair cable, and next one is a coaxial cable, and another is a fiber optic cable. So first this is the structure of the twisted pair cable. There will be a conductor. Here only we have so here let us see. Yeah, this is a conductor. So here only the source will be given, so the electrons are flow from here. So here there is an inductor. So it is a material which can does not conduct current. So in next one is a UTP and STP cable. See, this is a UTP and STP cables. UTP and STP cables. So here there is a plastic cover. It is mounted on the bottom of the insulator, and here there is a metal sheet, and it is on the STP, UTP and STP. So next, first we have to see what is the UTP and STP means. UTP means it is unshielded twisted pair cable, and STP means the shielded twisted pair cable. So next, these are the categories of the unshielded twisted pair cables, and so first you can go through this. First one is this is some specification, and that each specification that mentions own data rate in MB per second, and what are the uses, how to use by using this. Let us see the first one. This is an unshielded twisted pair cable used in telephone. So it is data is less than less than 0.1 and used in telephones. So likewise it is used in LANs, T1 transmission lines. So it is going on. So next one is the UTP connector. So UTP I have already told, is an unshielded twisted pair cable. The cost of the UTP is there are two parts. One is the female part, another is the male part. So this cost of UTP is less compared to the cost of STP. And this UTP unshielded twisted pair cable has each pairs of wire twisted together. Those wires are then wrapped in tubing without any other protection. This is a UTP, and this is the UTP performance. It is shown in the graph. The attenuations are mentioned in dB per kilometer and the frequency in the x-axis. So if we give see the gauge is this 18 means the diameter is 0.0403 inches. It is mentioned in denoted in inches. So like this. Next one is we have to see the coaxial cable. First we have seen the twisted pair cable. Next one is the coaxial cable. First we have to see what is coaxial cable. So coaxial cable is why we need this coaxial cable. Coaxial cable is type of copper cable. It is specially built with a metal shield and other components to block the signal interference. We have to block the signal interference. We use this coaxial cable mainly purpose. So it is primarily used by the TV cables companies to connect their satellite antenna facilities or the customer homes and business. So like this you can use. Here also there is a plastic cover and outer shield connector, and there is an insulator, and there is an inner conductor. Okay, next we have see that this is also the categories of coaxial cable. And next, BNC connectors. So what do you mean by this BNC connectors? So BNC connector is nothing but it is a bay owner nail connection. It is a bay owner nail concealment is sometimes is a British naval connector. So it's used to connect a computer coaxial cable in a Ethernet network. So here there is a BNC connector. So here there is a BNC connector, and here there is a cable. So it is a BNC transmitter, and here is a terminator. So these have to connect this to end. So these are the BNC connectors. Next, so coaxial cable performance. This is a graph. It shows this coaxial cable performance. And next one is a fiber optics. So fiber optics. So first one is this is a bending of the light. So fiber optics is a technology that is used to transmit information as pulse of light through strands of fiber made of glass or plastic cover long distance. So the main purpose of fiber optic is used for the long distance and high performance data networking. It is commonly used in telecommunication services such as internet, televisions and telephones. So first one is the critical angle. So I is less than critical angle refraction. So there will be less dense. So next one is the I is equal to critical angle refraction, and also greater than critical angle refraction. So next, optical fiber. So next we have to see in the optical fiber. So optical fiber is similar to the fiber optics. So it is also the technology that transmits the information as light pulses along a glass or plastic fiber. So here we can see the sender, and here the receiver. The upper and lower part are made up of cladding, and inside that is a core. So there the signal has been transmitted. So next is the propagation modes. The mode of operation has two modes. One is multi-mode, another one is single mode. In multi-mode there are two cases. One is step index and another is gradient index. Next, here you can see the diagram I have shown here. The multi-mode step index and multi-mode gradient index, and another single mode. Multi-mode means there is a source. Here in single mode there will be only one source that can be transferred from the sender to the from the transmitter part and the destination part. But in the multi modes there is so many sources it can be transferred and received at the destination. Next one is a multi-mode gradient index. That's also similar to that multi-mode step index. So next is fiber optics fiber types. What are the we have used here? Next one is a fiber construction. The fiber construction is shown here. I have there will be outer jacket. It is fiber optic construction is a cable consists of glass or silica core. Here there is be a cladding part. Inside that there will be a glass or plastic core is present, and outer that is the outer jacket, and in between that there will be a plastic buffer. So the core of the optical fiber is surrounded by a similar metal like glass or silica. It is called the cladding that has a refractive index that is slightly lower than that of the core. Okay. Next, this is the fiber optic cable connectors. One is SC connector and another is ST connector. Here I have shown the MTRJ connector also. Next, this is the optical fiber performance graph. So in y-axis I have mentioned the loss in dB per kilometer, and here in x-axis this is the wavelength. So next we have seen the unguided media. So now we have seen the guided media, the three parts, and now we have to see the unguided media. It is a wireless medium. So unguided media transport electromagnetic waves without using a physical conductor. This type of communication is often referred to as wireless communication. So this unguided media is an example for the wireless communication. So topic you have to see in this section is radio waves, microwaves and infrared waves. So first, the electromagnetic spectrum of wireless communication. Here the radio waves and microwaves. So next we have to see what is radio wave and microwaves and infrared waves. Here the radio waves is it is what is the difference we have to know. So infrared rays have a higher frequency than radio waves. Among these three, radio waves and microwaves, and among these two, the infrared wave has a higher frequency, so they have more energy than these two, because you can feel the energy of infrared rays as heat. These rays are often called as heat rays also. Infrared rays are electromagnetic waves with wavelength shorter than those of the radio waves and microwaves. This is the propagation method I have shown here. One is ground propagation, another is sky propagation, another is line of sight propagation. Then between the ionosphere layer on the Earth's surface, in ground propagation it is below 2 MHz. In sky propagation it is range from 2 to 30 MHz. Line of sight propagation is above 30 MHz. So it is a band. So next, I have shown here very low frequency, that is the range is 3 to 30 kilohertz, and the ground propagation, long range radio navigations. So in ground waves propagation we can acute low frequency, that is enough for that. But in sky wave we have to transmit more number of frequency, then only we need in megahertz like high frequencies. And in line of sight means we have to need like cellular phone, satellite communication. These are the main examples of line of sight communication. So there we need gigahertz of frequencies, because for example we have watched television means there will be some more number of gigahertz frequencies are generated, because we have to get the signal from the satellite communication through the our antenna for our television. So there will be some gigahertz for then this high frequency, the megahertz or kilohertz frequency, there some of the voice transmission or speech transmission, like that we need some frequency is enough. But for video transmission there will be more frequency we need. Next, what is wireless transmission waves? Wireless transmission, there are, I already told, there is a radio wave, microwave and infrared waves. So let us note point. The radio waves are used for multicast communication such as radio and televisions and packing systems. They can penetrate through walls. They can. It is highly regulated and use omnidirectional antennas. It is basically used in omnidirectional antennas. Next, this is the omnidirectional antenna. It can generate in anywhere. If you have any block also, that be scattered from that wall, the radio waves are generated. Next one is the microwaves. Microwaves are used for unicast communication such as cellular telephone, satellite networks and wireless LANs. Higher frequency range cannot penetrate walls, so use directional antennas, point to point, line of sight communications. So this is a unidirectional antenna. It can generate only in a particular direction. So here that we can use a dish antenna, horn antenna, like this antenna we have used for the microwave signals. So next one is infrared signals. The infrared signal can be used for short range communication in a closed area using line of sight propagations. So thank you for this. I have completed my transmission media. So thank you, sir.